Hi, my name is Dan. We're here today at Conestoga College in Cambridge to talk about how to safely set up and operate an oxy-fuel cutting system. Oxy-fuel is used widely throughout the welding and metal fabrication industry, primarily for cutting, but still also for welding. So the next and probably most important thing we want to talk about is staying safe. And the first step to staying safe is good personal protective equipment, or PPE. So our PPE is going to be, at the very least, a good set of safety glasses, natural fiber clothing and long sleeves, high-cut safety boots, and you want to make sure when you're wearing your long pants that they're covering your safety boots. If they're not, you may get sparks and spatter into your boots that can burn you. You also want to find a nice, good pair of gloves that are comfortable and will protect your hands. You may also want to wear hearing protection. It's not required. Oxy-acetylene is not that loud. However, it's always a good practice to get into. Beyond that, you're always going to want to wear a set of goggles with you when you're performing any welding or cutting. Beyond your personal protective equipment, we also need to consider safety in general. Safety in general includes things like being aware of your jurisdiction's guidelines on safety, whether that's your local, provincial, or state laws. Make sure you're following those guidelines. Beyond that, you also want to be aware of your operating envelope. What's going on around you while you're using this equipment? You need to be aware of anything flammable that could catch fire or anything explosive around you. You also want to be aware of everybody else who's around you as well. If there's people around you, you need to make sure that they know what you're doing and that they're going to be aware and safe while you're doing it. One of the primary components of the oxy-fuel setup is the gases that we need to use. In the case of oxy-fuel, we have oxygen and a fuel source. For us, we're going to talk about oxygen and acetylene. In this case, we have a high-pressure oxygen cylinder here. It is capable of holding up to 2,500 psi, and here we have an acetylene cylinder that has around 200 psi. Because of that, we've secured them with chains to the cart that they're on to ensure that no potential accidents may occur. Another thing to keep in mind with oxygen is that you need to avoid having any grease or any hydrocarbon-based cleaners on your gloves or on your hands, as these materials can become unstable in the presence of pressurized oxygen. With our cylinders, we have protective caps on both. When you're getting ready to use your oxy-fuel setup, you want to remove them, as I'll do right now real quick. Over here on the oxygen cylinder, we have a rupture disc on this side of the valve. Whenever there's excessive pressure or any kind of fault in the system, the disc will rupture and it will release the gas, so nothing goes horribly wrong. On the acetylene cylinder, there are fusible plugs. In a similar manner, they will actually melt and also release the fuel gas, again, if anything has gone wrong. Moving on from cylinders, we're now going to start to talk about regulators. Here we have an oxygen regulator. The purpose of the regulator is to reduce the supply pressure to your working pressure. Because of that, there's two gauges. One is for the supply pressure, the other is for the working pressure. To adjust your working pressure, you use this spring-loaded diaphragm here, and that will change the pressure coming out on the working side of things. Also equipped on regulators are flashback arresters, in this case, this right here. As well, it is a right-handed thread on the oxygen regulator, as well as all the other oxygen fittings. Here we have our acetylene regulator. Similarly to the oxygen regulator, it has a supply pressure gauge and a working pressure gauge. In this case, however, we're using left-handed threads on all of our fittings, from the cylinder side to the flashback arrestor, also equipped here, to the hose fittings and torch fittings as well. Again, we have a spring-loaded diaphragm valve to reduce our supply pressure to our working pressure. Moving along from regulators, we have a combination torch. What you see here is called the mixing barrel. It has valves on it for both your fuel and your oxygen supply. Attached to that, you may have a cutting head. Again, there's an oxygen valve on the cutting head and also a lever to initiate the oxygen flow. Another thing you may attach to the combination torch is a welding tip. These come in a variety of sizes, but they all look generally like this. Let's move on to assembling things. The first thing you want to do is to check your valves. Just make a quick visual inspection to ensure that there's no debris or particles in there that may work through the system as you're using your oxy-fuel setup. In the case of the oxygen, you also do want to quickly crack the valve to, again, just clear out any debris that may be in there. So we'll just do that real quick. Make sure to step away to the side so that you don't get oxygen all over yourself. And just crack the valve real quick. That's all it takes. You do not do that with the acetylene because it's a volatile gas. You don't want to get that out into the atmosphere if at all possible. So moving on from there, we're now going to connect our regulators. We'll start with the oxygen regulator. Again, this is a right-hand thread, and we'll just hook it up. Always check, whatever you're hooking up, that the mechanical fittings are in good condition and that there's, again, no debris that may work its way through the system. So we'll connect the oxygen regulator like so. Where you can, try to ensure that the gauges are vertical. It's always good practice. After you've hand tightened it, take a wrench and ensure that it's completely tightened on. Next, we'll connect the acetylene regulator. Again, this is a left-hand thread in this case. The distinguishing mark is that there's a notch on the fitting. Again, check that you have good fittings and that they're free of debris and any contaminants. And we'll now connect that regulator. So again, when we get this tightened on, we're going to take a wrench and make sure it's well attached. After that, we'll move on to our hoses. Again, when you're attaching your hoses, make a quick visual inspection that there's no debris. Also note that the hoses are color-coded. However, the color that's used isn't consistent, so just make sure that you're aware of whatever the color coding happens to be. It's always important. So in this case, we'll attach this hose to the flashback arrestor on the regulator, and same here with the fuel. Again, ensure that all your fittings are tight. After you've connected your hoses, you're then going to start attaching your torch. So, again, we have the barrel and our hoses. Quick visual inspection that there's no debris. And ensure that you're connecting the proper hose to the proper valve. Also, while you're doing this, you need to ensure beforehand that your valves are fully closed so that you don't have gas flowing immediately when you open the cylinders. Sometimes they're a little tricky. Again, ensure that with a wrench, your fittings are tight. After you've connected your mixing barrel, you're then going to attach whatever attachment you choose. Check that there's no debris in the fittings and ensure that you have O-rings where they should be. And then go ahead and attach your attachment. Where exactly the valves are located is up to the operator. I tend to line up the oxygen valve on both the attachment and the barrel. Just hand tighten it so that it's snug. In the case of cutting, we also have different size cutting tips. Again, whenever you are attaching a tip, ensure that there's no debris and tighten that down with a wrench. Typically, the manufacturer will have recommendations on what size tip to use depending on what size material you have. And then next, we'll talk about operating the oxy-fuel setup. Now that we've assembled everything, we're ready to start operating our oxy-fuel setup. So first things first, let's get all the appropriate PPE on. Start out with the gloves. And the fancy goggles. So now that we're ready to go, we're just going to make sure that all of our fittings are tight. Just one last double check real quick. Oops. Also check the fittings that you've attached to the regulators, just to be sure. Okay, so at this point, we're ready to start pressurizing the system. So when you do that, just ensure that you're on the opposite side of the regulator, like so. In the case of acetylene, typical applications, you'll just open the valve 1.5 turns. So I'll just do that right now. After the valves are open and ready to go, we're going to set our working pressures. Working pressure is set here with the diaphragms. After we've set our working pressure, we're going to open the valves on the torch and make sure that our pressures are maintained the way we want them when the valves are open. In the case of a cutting combination, you can open this oxygen valve all the way, as you've got the separate oxygen valve on the cutting attachment itself. So we'll just quickly ensure that our working pressures are where we want them. After we've set our working pressures, we're ready to light the torch. Double check real quick that all of our fittings are tight. Try not to over tighten them, just make sure that they're tight enough to do what they need to do. At this point, we're going to start to set our pressures. So, over on the oxygen cylinder, we need to make sure that the diaphragm is loose and there's no tension. At that point, we can start to introduce pressure to the system. So to do that on an oxygen cylinder, we need to open the valve all the way. There's a double-seated valve in an oxygen cylinder, and it won't function properly if it's not open all the way. So we'll just quickly open it, slowly introducing pressure to the system, and again, opening the valve fully. Once the oxygen valve is fully open, we'll open the acetylene valve and introduce pressure to the system again. For typical applications, you'll open the acetylene valve 1.5 turns. So we'll just do that right now. After you've opened the both cylinders, you then want to set your working pressures with the diaphragms. So we'll start off with oxygen and set our working pressure there. And again, with acetylene, we'll set our working pressure. It's important with acetylene never to have your working pressure over 15 psi. Above 15 psi, acetylene becomes unstable and it'll break down. So ensure that no matter what pressure you choose, it's under 15 psi. After we've set our working pressure, what we want to do is open the valves on the torch and ensure that when we have gas flowing through the entire system, that our working pressures are maintained where we want them. So we'll just do that real quick. In the case of a cutting attachment, you can open the oxygen valve on the barrel all the way because you can adjust it up here on the cutting attachment. After you've adjusted your oxygen working pressure, then again adjust your acetylene working pressure, ensuring again that you're not above 15 psi at any point. Now that we've adjusted our working pressures, we need to ensure that there's no leaks in the system. If there are, there may be an accident. So we'll step over here and do that. To do a quick leak detection, we'll start at the regulators, and ideally you want to ensure that every fitting is free of any leaks. So to do that, just make sure you have an appropriate leak detection fluid and lightly spray it on all of the fittings. Spray the torch. So it seems that we're free of any leaks. So at this point, we can now light our torch. Prior to that, make sure that you're wearing your goggles so that you're being safe. To light the torch, I prefer to take the striker in one hand, open the fuel valve like so, and strike a flame. When you're comfortable with where the fuel flow is set, you can then open the oxygen valve, and you want to adjust towards a neutral flame. I think I have too much gas, so I'm going to turn it back. Make it a little quieter. And there we have our neutral flame. Now you're ready to do any cutting that you may need to do with the oxy-fuel setup. So there are 3 types of flames that you can get with an oxy-fuel setup. Right now we have a neutral flame. Not sure if you can see, but there's no feather coming out ahead of the preheat cones. The preheat cones are nice and rounded. So again, this is a neutral flame. Really quickly, I'll show you what a carburizing flame looks like. As you can see, we now have a feather in front of the flame. This is because there's not enough oxygen to completely consume the acetylene going through the flame. And this is known as a carburizing flame. The opposite to a carburizing flame is something called an oxidizing flame. You should notice it'll get a little bit louder as I add more than enough oxygen for the flame. That is now an oxidizing flame. The flame tips are a little bit more pointed. And as you can tell, it was much louder. We're now back to a neutral flame. So one last thing to discuss real quick is the appropriate shutdown of your torch. Your manufacturer will have specific recommendations for your torch. In this case, we're going to shut down the oxygen and then the acetylene. O before A. At the end of the day, to correctly shut down our oxy-fuel setup, we just want to follow a few quick steps. After you're done your welding or cutting, make sure that your valves are closed on the torch. And then at that point, you're going to come back to your gas tanks here, and you're going to fully close both the supply valves. So I'll do that here with the oxygen first in this case. And also with the acetylene. At this point, you want to bleed the system and get all the gas out, so we'll do that. And the acetylene. Once there's no gas in the system, we're going to back off the diaphragm valves and release the pressure on those. You want to go until you can feel that they're loose. So now that we've got all the gas out of the system, we're safely shut down. However, if you were to need to move the portable setup, you want to make sure that you take the regulators off by the opposite of how you put them on, of course, and then make sure that if you're about to move the cylinders, that you've put your caps back on the cylinder prior to moving it at all. And then you're safely shut down and safe to move around.